right, so welcome everybody to this new episode of the Coffee Breakdown podcast. I am Luca, and I'm really honored to have here as a guest Daan Boer, who is a PhD student at TU Eindhoven, and he's working on very interesting project related with LXCat and a new type of platform for sharing data. And this is the topic of today's episode. And I also would like, well, first of all, to thank you, Dan, and also to say that this is the second episode on LXCat that we have in this podcast. The first episode is together with Professor Jacob Stevens. So if you haven't seen that, and if you want a bit more background information on what is LXCat and so on, so you can also check that video, and maybe I'll put the link in the description. So thank you, Dan, for your time, actually, and for your interest and for accepting the invitation.
Well, thank you for such kind words, Luca. I think I am the one who is honored to be here, but okay. I think this can be very fun.
Yes. So first of all, I really don't want to repeat a lot of things on LXCat and so on, right? A lot of people watching this video think they know, otherwise they can watch the previous video.
Yeah.
But let me ask you, like, first, actually, let's start from introducing yourself. So what do you do and so on? What is your project about? What do you like doing in general?
Yeah. So I'm a PhD student, as you already told, at Eindhoven University of Technology. I work with Jan van Dijk. He's my supervisor. That's also where I did my master project. So during my studies, I did 2 master degrees, one in applied physics, specifically plasma physics, and one in data science. And I think that all of the projects that I've done are always on this sort of edge between plasma physics and data science. And that's actually also how I ended up here, right? In essentially data management for low temperature plasma physics.
Okay, so data science, you studied which type of topics or which courses did you attend?
Okay. So it's very broad, of course. When I say data
Yeah,
science, usually
yeah,
people immediately
exactly.
think of machine learning or deep
Yeah,
learning, which
exactly,
are sort of
exactly.
the hot topics. So yes, I also did machine learning and deep learning, but databases, for example, is also
Yeah,
a big topic in data science, right? And also
yeah.
more generally, I mean, data modeling, for example, structuring your data.
Hmm.
Um, so yeah, it's a bigger field than just machine learning, but I did
Okay.
a bit of everything.
Okay, okay, that's very cool. And you did a double master, you said, right?
Yes, yeah.
Oh, that's interesting. Okay, because these are things, this kind of cross-pollination is not very common, at least in plasma community. One tend to specialize on, plasma physics, but
hmm
not have this other, part of the world.
hmm
And okay, very, very interesting. So, and then, so now you're working on topics related with LXCat.
Yes,
So
yeah,
what was your idea? Because I remember you started this already from your master project, right?
that's true. Yeah. So, um, well, LXCat has existed now
Mhm.
already for quite a long time, right? I think maybe 10 years already.
Yeah, probably,
Uh,
yes.
yeah. And well, LXCat was started with a certain idea in mind, and it served us, of course, very well. But
Mhm,
at some point, um, you outgrow
mhm,
what you've built, and so there were, you know, a lot of things that we wanted to improve on LXCat, or that initially other people wanted to improve on LXCat, and then I came into the picture. Um, yeah, so the idea was actually to build a completely new data platform under the
mhm.
banner of LXCat that treats some of these problems um, that we
Yeah,
have
yeah.
now or had before. And
Okay.
that's one aspect, right? And then of course, then you can do all kinds of interesting things with the data. So for my project personally, it will probably also involve some machine learning.
Mhm,
But the first step is really structuring this data
mhm.
and working on LXCat, but also maybe on chemistry data, for example.
Okay, so this is okay, really interesting. Okay, maybe we will discuss a bit more in detail some of this topic
hmm
you mentioned. It's also let me start maybe saying why do you think LSCAT is important for the plasma community?
Yeah. Um, I think LXCat, and I think I'm right to say so, is one of the most important data platforms in low temperature
Yeah,
plasma physics. It has grown to be one of the most important. And it is one of the very few places where you can actually get data that you need to do a plasma simulation, right? Then in this case,
yeah.
it's specifically data related to charged particles interacting with a neutral
Mhm,
particle. So for example, cross sections that you need for a Boltzmann computation to do your electron kinetics, but we also have swarm parameters,
mhm,
potentials, differential cross sections, and so on. So I think in general, it's just one of the very few places where we share this data with one another.
mhm.
Um, and that's why it's so very important. It has grown to be
Yeah,
so very
yeah, I
important.
agree. In fact, from modeling perspective, from someone doing modeling, I cannot imagine doing modeling without LXCat, right? So I've
Mm,
started with this platform, and now it's also part of my everyday use. So
mm,
I totally agree with you.
mm,
So and then so I would like to make a sort of detour, maybe think about because you mentioned very interesting concepts and so on. I've also read a very nice paper recently by colleagues Luis Alves and so on about the standards in plasmas, right? And
mhm,
I would
mhm,
like just to discuss with you and to chat a little bit. Why do you think
mhm,
we need like standards in plasmas? But I'm thinking specifically about data or sharing data or
mhm.
even in models.
Yeah, I think there are many reasons why you
Yeah.
would want to to standardize.
Mhm,
But one of the main things, and that's also one of the main pillars that we are trying to improve in, trying to work on, is of
mhm.
course reproducibility of results.
Yeah, true.
Right, and on the one hand, you have the actual codes, the simulation tools that you use to obtain your
Hmm.
results, and on the other hand, you have the input data.
Hmm.
And this is of course the thing that we are initially working on.
Yeah.
Um, so essentially, standardizing your data or your data format allows us to communicate your data in a more
Hmm.
effective way. And it also allows us to, for example, start building sort of an ecosystem of tools around it, right?
Hmm.
These can be practical tools, these can be
Yeah,
simulation
true.
tools, but also educational tools,
Yeah, true,
for
true.
example.
Yeah.
So these are all reasons why you might want to might want to standardize, but maybe also um, standardizing a data format forces you to think about what
Hmm.
is really important.
Yeah, this is very good. I really like this this comment actually.
Mhm. Me too.
Because yeah, because for me it's it's easy to ask you, yeah, just build a new platform that has different functionality and so on. But then you
Mhm,
can
mhm,
ask back, okay, but which information do you really need, right? Because if I need to build another platform, right, that is different than the previous one,
mhm.
right? What do you need as a modeler, for example, or as someone who interprets experiments? So it's a very difficult
Definitely. Yeah.
question. Yes.
Yeah. 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 Yeah.
Another point it came up in the discussion we had also at conferences is
Mhm.
also to have good referencing of the sources, right? And I think this is also what your work helps so
Definitely.
to reference the good work that provided this data. And, yeah.
Yeah. And this is across the board, right? So this is
Mm.
from the people that initially measured or computed maybe the individual cross sections to the people that put them together
Mhm.
and published them as a set, maybe
Mhm. Yeah.
to LXCat itself, um, and also making sure that it is reproducible through. I mean, we will see in the demonstration, but making sure that it's also reproducible and that the correct citation is given, such that the data is
Yeah. Yeah.
easy to be obtained by someone else.
Okay. Yes. And regarding some scientific questions, of course, here it comes the problem again. There are some things that, in my opinion, are not completely solved. Partially also because we work in different type of applications, right? And it's normal that there is variety in our community.
Hmm.
But it's
Hmm.
like, for example, I don't know, do we need the angular dependence on the cross section? So is it really important to have this differential cross section, or
Hmm.
do we need to know exactly the quantum state of the molecules, for example, or the atoms? It's like
Yeah.
because this changes dramatically, I think, how you build your platform, I suppose.
Yes. And
I
of
mean,
course,
it's not a question to you, of course,
yeah,
that I
I mean,
expect, but
I'm not going to give you all the
it's
answers
just
now, Luca,
to
but
think together about these topics, of course.
yes. So one of the things that I think we try to do is
Hmm.
to um, be flexible in a way, to
Yeah.
so to make
Okay.
technical choices which result in that in the future, if we are certain like we need this angular dependence, then we can be flexible and modify the platform in such a way that this is now a possibility.
Yes.
So these are things that we try to keep in mind to hopefully um, not get into a situation again, maybe where we need to make a drastic change. And but of
Okay.
course, we might have to. It's you never know what's going to happen. But
Yeah, that's interesting. Yeah. And related to the tools that you
mm,
mentioned, how do you see these developing? For example, in terms of model, I know LXCat already integrates some tools. I think about the Basic Class, right?
yep,
Do you
yep.
think there will be more models that
Um,
are are supported or that are, recommended?
well, recommended. That's they use a word that I
Yeah.
I
Ah,
cannot
that's true.
use as a member of the LXCat team. But I think so, yes. But this might be through different means, right?
Mhm,
So Basic Plus has always been available as part, let's say, of LXCat, of the LXCat website, and it still is, also in a new version.
mhm.
But in the way we set up the platform, it's now also a lot easier for other tools to be integrated.
Yeah, I see.
And this can be either as part of LXCat, and there's still discussion going on whether we want to do this, and because the tools, of course, need to be verified to some extent. Um, and on the other hand, also as standalone applications. So as a
Yeah.
separate web
Okay.
application, for example, that talks to LXCat and can also function
Mhm.
similarly, but not within the scope of LXCat, but right outside.
Yeah,
Um,
yeah. So you can take data from LSCAT, for example, put it in this code and reproduce these results that are maybe published
yes.
somewhere. I think so. And this is a topic I quite care about. I was also discussing with Jacob to
Hmm.
try to expose ourselves in terms of assumptions that also we make in the model.
Yeah.
Because, for example, already the type of cross-section that you choose within LSCAT it's already part of assumptions of your model, right?
Yep.
And so, and this is part of all this standardization of processes of data, of developments that we were discussing about, I think.
Yes, and I think we can still do a lot here. So
Yeah.
what we've done up till now is just to provide a foundation
Hmm.
and to with the knowledge that the LXCat team has gained over the years,
Hmm.
make the changes that we feel necessary. But then I think together with all of the community, we need to do a lot of iterations in
Yeah.
expanding this format, right? Expanding this standardization, because I think we can do a lot better still
Hmm.
in objectively classifying our data. So validity ranges, for example,
True,
in
true.
so
Yeah.
for different parameters in which the data is valid, but also specifying more explicitly, for example, with what methods data has been validated.
Hmm. Hmm.
Um, and I think there's still a long way to go here.
Yeah, yeah, of course, of course. Okay, so let's maybe talk a bit more concretely,
Mhm.
what do you think are the issues or, things that can be changed in the current LSCAT platform?
Right. Um, so there's a number of things, of
Yeah,
course.
yeah,
In my presentations, I always like to do this along three axes. Right? I
okay,
think you've seen maybe
yeah,
my presentation multiple
yeah.
times. But I always like to think about the data format that we use. Right. So how
Hmm.
do we structure our data?
Hmm.
Um, how do we store our data?
Yeah,
And then how do we allow users to interact with our data? And I think we can improve in all three of these areas. But I mean, originally I think LXCat was built with sort of this idea of complete sets in mind,
yeah.
right? So usually these are relatively small data sets that maybe contain
Hmm.
three cross sections, and that allow you, when you use a two-term Boltzmann solver, to get good
Hmm.
good results for your swarm
Yeah.
parameters. and it was built in such a way to support these types of data. And of course, this was sort of evolving at the same time as or in line with POSIX Plus, I should say, right? So the input format is essentially, so
True.
the cross-section format is essentially the POSIX Plus input format, right?
Yeah, true.
And there are simply some restrictions there.
Mhm.
Um, so we can, first of all, structure our data in a more standard way, I would
Mhm.
say. So using a standardized data format, you can think about
Mhm.
JSON or YAML or TOML or
Yeah.
XML or whatever we have these days.
Mhm.
Um, and then you can go one step further. You can think about schema, so explaining
Okay.
or creating some sort of a blueprint of what the data is allowed to
Mhm.
look like, right? So what each of the fields means, for example.
Mhm.
So there's some improvements that we can do here, um, which I think you will also indirectly see in the
Okay.
demonstration.
Mhm.
And but doing this, so for example, one of the concrete things that we can talk about is how we identify states, right? States of
Mhm.
different species.
Mhm.
And in current LXCat, we allow everything essentially. It's just that
Mhm.
contributors can choose an
Okay.
arbitrary string to identify an excited state.
Mhm.
But of course, as physicists, we already, we made some rules about how we specify these excited
Mhm.
states, what quanta we use, for example.
Mhm.
And we can be a little more strict here. On the other hand, we cannot always be uh, completely strict. We don't always
Yeah.
know what the exact state
Yeah.
is.
Mhm.
Yeah, the argon star example, the
Yeah,
helium
true,
star
true.
example.
But also simply because sometimes, cross sections have been derived with different methods, right? Sometimes you can
Hmm.
measure cross section for a single process, like with beam experiments, but sometimes you will derive cross section from swarm analysis. So what
Hmm.
you get is a magnitude of the total cross section, right? And
Yeah.
simply you
Yeah.
cannot distinguish individual states, individual
Yes.
processes for excitation. Or...
Yeah, yeah, and so both need to be supported in some way,
Okay,
and
I
this
see.
you
Yeah.
need to take care of this.
Okay.
Yeah, and then doing this, so structuring your data a
Uh-huh.
lot better, also results in that you need different solutions for how you store your data.
I see.
But it also opens a lot of opportunities, for example, in how you allow people to interact and explore
Mm-hmm.
the data.
And in
Um,
terms of, okay, maybe here we need a little bit more background because it's
mhm.
very technical what you do.
Yes.
Just can you explain the difference in the type of database that you have chosen in the new version with respect to the old one?
Right. Um, so in the current version of LXCat,
Hmm.
we use MySQL, which is
Okay.
a relational database, as we call it. I think most people will be familiar with this. It's
Yeah.
like sort of like the standard type of database where we have tables and
Yes.
relations between these tables, and we can query it using SQL.
Okay.
Um, and these databases, they are very optimized because they have been used for a very long time.
Hmm.
But when we go towards data sets that are very heterogeneous, so they have data
Okay.
that can has a very different structure between different objects, these databases are not generally the best fit.
Okay.
And then you'll have to start looking under the umbrella of what we call NoSQL, which is
Hmm.
essentially every type of database except for relational databases or SQL databases, if you will.
Hmm.
And there are many different choices here. But yeah, we chose a specific database. It's called ArangoDB. It's open source. You can look it up.
Uh-huh.
Which is what they call a multi-model database. It's all still very technical, Luca. But
Yeah, yeah. No, but it's fine. It's fine.
okay. So essentially, a multi-model database sort of picks features from
Okay.
different database paradigms. And
Hmm.
in our case, we were really looking for two things. On the one hand, we were looking for a database that could work natively with the document format that we chose, which is
Hmm.
JSON,
Yeah.
JavaScript object notation. And on the other hand, um, we wanted a database that would allow us to model some parts of our data as a graph, so nodes and
I
edges,
see. I see. Okay. And this
because
is,
that's
yeah, kind of, you want to describe, and maybe also in the future we discuss also very much interconnected data, with this,
yes.
yeah.
If you think about reaction networks, for example,
Yes, exactly.
right? So
Yeah.
essentially states linked together through reactions. Yeah, there are very interesting questions that you can ask such a database, especially when we go to full chemistries. The
Yeah, yeah.
shortest path connecting, weighted with whatever,
Mhm.
connecting two species, for example, in a specific chemistry that you selected,
Yeah, yeah.
and stuff like that. This is what a graph database allows you to do,
I see.
and it might also be a little more efficient for some of the type of queries that we want to do.
Okay. And regarding the format, well, you already mentioned JSON.
Mhm.
Is there like specific reason why you're choosing JSON over, I don't know, XML or some other ones?
Yeah, so I think many choices would have been okay.
Yeah, I think so. Okay.
We chose JSON specifically because it's very well integrated in the web environment.
Okay.
It's relatively easy to read, but it's very easy to parse, and it has a very big ecosystem of tools surrounding it. So
Yeah.
if I want to write a parser or if I need a parser for JSON in
Mhm.
any programming language, essentially it will already exist.
Mhm.
And then there's also many of these other tools that surround JSON, such as, for example, JSON schema, right, which is this
Mhm.
meta language that allows you
Yeah.
to describe what your objects are allowed to look like. And I think this was um, the main aspect why we chose JSON.
Okay, okay. And talking again about these databases, please correct me if I'm wrong. One
Mhm,
of these problem that was striking me when I saw the current LXCat version is this multitude of different how do you say species of different at some point you have cross section for different excited states, and these are tagged in a very different way that you can select, but it's very
mhm,
difficult also to realize, oh, there are also, I don't know, rotationally resolved cross section, and I have to click on that to
mhm,
retrieve them. It's not immediate, let's say.
mhm.
It's probably one of the limitation of these relational databases. Am I correct?
Um, yes, but it also really has to do with how we structure the data itself.
Yes, okay,
That some
okay.
of these relations might not be explicit in the data,
Yeah,
and
yeah,
therefore we cannot
exactly.
leverage them in the front end. So, structuring your data in a nice way, in a good way, and then storing your data in a good way results in that you can leverage all of the relations that are implicitly present in your data when you present it to the user.
Okay, very good. So, okay, I think this gives me a very good assist to move to actually a live demonstration.
Hmm,
Before moving that, I would say, well, first of all, if you can share the screen and let's see if everything works properly. And
yeah.
second is that, of course, we are recording this in the summer of 2023.
Mhm,
It's end of July now, so maybe the episode will be released soon after a few weeks. And of course, this is a project that is that it's work in progress and things may change in the next few months even, or even a few weeks. So
definitely.
this is one of the first recorded demonstration that we had, right?
Oh, I think so, yes. We've already presented some of this work to
Yes, yes, of course.
contributors, for example,
Yeah, yeah.
but I don't think we might not have a public um, recorded demonstration.
Yes, exactly. So, but I think
Uh,
this is also very useful to get interest from the people to your work in general, to get used to this new platform that you're building and so on.
mhm.
So, okay, please, you can start your demonstration, maybe showing us some relevant examples and so on, and how you structure the data, how you can retrieve the data and so on.
Right. So yes. So exactly. What I want to do here is just look at it from a user perspective.
Mhm,
So to just go through all the steps of selecting my data, exploring what data is there, and then inspecting the data. And I can also show you a preliminary Bolsic calculation in the browser.
mhm.
But what you see on screen now, you can see the screen, right, Luca?
Yes, yes, perfect.
Great. So what you see on screen now is essentially the development environment of LXCat 3, what we
Mhm,
what we call the next generation of LXCat. And what I can do is I can go to this cross sections page. And what you should know is that in this version of LXCat, we started by focusing on cross sections.
Mhm.
So all the data that you're going to see here is are cross sections. And of course, in the future, we are planning on expanding again to potentials and all the other types of data
Yeah, yeah.
that we have.
First of all, sorry if I interrupt because maybe something you will talk about. I really
Mhm.
like you divide the cross-section and cross-section sets. So this
Ah,
is something,
yes.
you know, as someone doing modeling, it's like I'm amazed by this already because it's very
Nice.
useful. No, no, it's very useful, right? Already, you know, and I do it myself, sometimes mix a cross-section from different sources. For example, I wanted to have internal excitation or
Mhm,
stepwise excitation ionization, and
mhm.
I take it from BSR database, and the other ones I take it from Phelps database, but they're maybe derived in a very different way, right?
Yes,
Whereas
yes,
here you provide the sets already. Okay, sorry, it was
yes.
just a
Yeah.
comment.
Yeah, you have to be very careful when you're
Mhm. Yeah,
combining data like that. Of course, as you will know. Um, but maybe I can show you as well. This is also something that we can now, because all of this information is explicitly in the data. We can also warn about this, right? When you are combining data from complete sets and incomplete sets, for example.
exactly. And this is a feature that was missing, in my opinion, in the previous version, although you can retrieve the same data probably.
Yes. Yeah.
Okay, okay.
Okay.
Yeah, please.
Let's go. So essentially what I have in front of me here is sort of a template of the reaction that I'm interested in, right? So I have a left-hand side of the reaction, the right-hand side, and then I can choose the type of reaction that I'm interested in. And then on the right-hand side here, we have, do you see my cursor? I think you do,
Yes,
right?
yes, I can
Yes.
see.
Okay, great. On the right-hand side, we have
Hmm.
essentially all of the contributors of which the data is currently in the test set. So this is also something that I should mention. All the data that you see here is our testing data.
Hmm.
So it is not necessarily been checked very thoroughly, but this is just the set to test whether all of the systems that we put in place actually work, right?
Yeah,
Whether
yeah.
the choices that we made actually make sense as well.
Hmm.
So I can essentially choose where I want to start, but maybe a logical choice is to start on the left-hand side and then to select a species that I'm interested in.
Hmm.
And here's one of the new features that you'll immediately see, that we sort of have this stepwise selection of the species that I'm
Hmm.
interested in. Then I can sort of drill down into more and more into the specifics,
Oh
right? So
yeah.
if I take, for example, a molecule here, start
Hmm.
with N2, then immediately you'll see that I get results from 3 different data sets. They are
Hmm.
all from IST Lisbon, as you see here on the left hand side. And then what I can do is expand them, and this should seem pretty
Yeah.
familiar, right? We have this description, which for now just literally comes from LXCat, because this data set was already published on LXCat. And then I can inspect already what kind of processes I have
Hmm.
um, in this data set. So you can see some electronic excitation, some vibrational excitation,
Hmm.
also some excitation that is both electronic
Yeah.
and vibrational, and an ionization reaction, for example.
Hmm.
Um, and so one of the things that I immediately want to highlight here is that you also see this reference here, and
Hmm.
everywhere on the new platform, what you'll see is that these references are clickable. So if I click on this reference, I will be brought to the original publication that presented this data set in this case. But this is also true for the references that point to the original sources of the data, for example.
Yeah, yeah.
Okay, so then what I can do is, for example, on the left hand side, we only have data for the electronic ground state of nitrogen, as you see here. So that's my
Hmm.
only option. But then I can also start selecting a
Hmm.
specific vibrational state that I'm interested in.
Yeah.
Right. So if I click the vibrational ground state, then you'll see that in my selection here, only interactions with the vibrational ground state on the left hand side remain.
Hmm.
And we have 2 sets left that have this type of information. And
Hmm.
then, of course, I can go even further and also select a specific rotationally excited state that I'm interested in. Then you see that only one interaction remains, this one.
Hmm.
Um, and in this way, I can really specify in which exact species or interaction I'm interested in. This is, of course, especially interesting also with state-to-state data.
Yes, yes.
Um, by the way, just feel free to interrupt me,
No, no,
Luca.
no,
That's
please.
no problem.
No, no, that's fine. Actually, one of the important things, as you mentioned about this referencing, is to know how these cross sections have been derived.
Mm.
because this is something that sometimes we as a modeler neglect a little bit.
Mm-hmm.
But it's very important. Do this come from swarm analysis, from beam experiment, quantum mechanical calculation, or so on? And I
Yeah.
think this can help also us to assess which type of assumption we are making in model. Yeah,
Yes. I mean, this will definitely help with that in that you can very easily find the paper that originally
exactly. Yeah.
published the data. And of course, if you read the paper, you will know where the data came from.
Hmm.
But then again, I think we can do a little bit better here and already, um, you know, add a property to our data, a bit
Hmm.
of metadata that already
That's true.
tells
Yeah.
you where this data, how this data was originally obtained. But
So and
that's yes.
yes, please.
No, no, go ahead.
No, so then you showed this sort of state-to-state type of approach, but it will also be possible, I think, to have some lumped states, so
Yeah.
a bit more generic.
Yes. So essentially, we distinguish three different types of states, right? We
Mhm,
have single states, so the states that we've been looking at, so that have a good quantum mechanical description, let's say.
mhm,
We have compound states, which is essentially lumped states, but we know exactly of which single states they consist.
mhm,
And then we have what we call sort of unspecified states, which are lumped states, and we don't know
mhm,
what the constituent states are. And I can show you an example of this. So again, in nitrogen, you can already see this, where we have this
mhm.
interaction. Um, for example, this one, where we
Yeah.
have sort of this v equal 5 or 6 or 7 or 8 or 9, which
Mhm,
is a lumped state, but we know exactly um, oh, which of the what
mhm,
are its constituent states. And then, of course, we also have the example of argon star, for example. So if we look here, we
mhm.
also still
Ah,
have
okay.
this
Mhm,
notion. So sort of this escape hatch that if we don't know what are the
mhm.
constituent states of this lumped state, we are still allowed to use a star, for example, to indicate okay, this is a more unspecified type of state.
Okay, okay. Yes, thank you very much. Um, yeah, and another thing was curious to ask, maybe this is also part of future work, is
Hmm.
integration with other codes. Now there are specifically about electron Boltzmann equation, several codes that are open source,
Hmm.
and I know that in some way LXCat was also built around Bosic Plus in the future. I'm wondering if there will be integration to, I don't know, Loki B or some other codes as well.
Yes, and we are actually also working on this. So there is a version of Loki B that can already work
Hmm.
with this new data. But in the end, what it's about is that all of the work that we do now is
Hmm.
completely open source. So this is also one of the things I wanted to share. I can very quickly hop over to the GitHub page that I already have open here very
Yes.
conveniently. All of the work that we do on the development of LXCat is open source.
Hmm.
So what we also sort of want to achieve is that um, people are invited to contribute to LXCat.
Hmm.
And that can also be through, for example, working on an open source tool and
Hmm.
allowing that tool to be able to work with the data that comes from LXCat. Yeah, so this is definitely one of the things that we're working on. Also from another perspective, because it's just simply very important to have multiple carrier applications that you can
Hmm.
test all of your changes
Hmm.
against, right? To
Yeah.
verify whether maybe some choices that you made in how you structure your data are actually um, practically, feasible
Hmm.
or useful. Okay.
Okay, yes, and in fact, I think this is very interesting because it connects with the standardization that we discussed before, right?
Hmm.
So you
Hmm.
made your work open source and you made it easy or attractive for people in the community to contribute. And I think this will help also of getting like good quality data and eventually set of cross sections or reaction mechanism and so on that are well established, I would say. Yeah.
Yeah, I hope so. And on the other hand, also um, sort of. take some of the burden, let's say, from the LXCat team,
Yeah.
because it takes a lot of work to maintain all this, right? And also to
Mhm.
develop something like LXCat. And
Yeah,
this
yeah,
is a way to attract. Hopefully, this is a way to attract more people, because open sourcing alone, of course, isn't enough, right? You
yeah,
also
yeah.
need
I
good
agree.
documentation. You need some sort
Mhm.
of PR, and then you also need educational content that allows
Yeah, that's
people
true.
to hop on board.
Mhm.
So there's more to this, but
Yeah, actually, we may discuss about that actually, and maybe
ah,
later on. So that's very interesting that you brought. Okay, so this is essentially how the new platform will look like. Um,
yes, yeah,
do you want to
of
add
course.
some other topics or some other announcements and so on, or so what
Uh,
are the next steps of your work?
okay, yeah. Well, what I can do is I can show you some of the other pages as well. So
Hmm.
to finish the demonstration a little bit more, and
Yes,
then we can talk a bit more about what the next steps are.
yes, perfect.
Um, well, maybe one more thing that I want to show, also
Hmm.
with this selection of states, is
Hmm.
we more and more we get these very intricate quantum mechanically computed data sets,
Yeah,
right,
true.
that are
Very
state
nice.
to state. And this is a great example. I think it's a state by, or a set by Liam Scarlett, which is published in
Mhm.
2021, and it's completely vibrationally resolved for the hydrogen molecule.
Yeah.
And this is a huge data set, right? It has 5,000 reactions and about 400 or 500 species.
Hmm.
And in the current version of LXCat, we wouldn't be able to host this simply because of how we structure the data and how we present it to the user.
Yeah.
Um, but now you can really see where this sort of new interface shines. I can also select based on the right-hand side. And what I can do is, for example, say that I'm interested in a specific vibrational
Hmm.
target state, and then a specific electronically excited state on the right hand side. And you can see that now 4 of these interactions remain. That specifically on the left hand side, where we have the vibrational
Hmm.
ground state, on the right hand side, we have a very specific electronically excited state. So this really allows us to sort of um, explore this very large data set and
Hmm.
find the data that I'm specifically interested in. But on the
Yeah.
other hand, of course, we still have, and I already showed this very briefly, we still have this notion of a complete set,
Hmm.
a set of cross sections, which, for example, might be fitted to experimentally obtained swarm parameters.
Hmm.
And this is also still supported. So sort of we sort of bridge the gap between, on the one hand, this more traditional way of providing these data sets, and on the other hand, these larger state-to-state cross sections, and both are, well, equally important, I would say, and both are supported in this way.
Yeah, yeah. Okay, that's great actually. Yes.
Now maybe let's quickly look at the data inspection page. So now I select a specific nitrogen data set from IC Lisbon. Then I can
Hmm.
click on this plot selection button,
Hmm.
and this is what the data inspection page currently looks like. So I think what the most important thing here is again related to reproducibility, and on the
Hmm.
other hand, referencing. Right, so you can, for example, in the top right table with all the processes, you can see that we very clearly state from which references this data comes from.
Hmm.
And the references are in this table down here. And again, all of the links are clickable, so you can actually find the original papers. And then we go one step further, where can immediately download all of the references that are attributed to this data set. So that includes the references that are coupled to specific processes, right? That are the source of the data. That includes the reference where this data set was published. That includes a reference to LXCat, and that includes a reference to this exact page that I have in front of me right now, such that in the future, if someone else wants to reproduce, for example, my
Hmm.
results, want to obtain my data that I used at some point in the past when I published this paper, will be able to find very easily.
Yeah, yeah, I
Um,
think this may improve also, the quality of the papers themselves because you obtain results of a model with this set of cross-section. You know exactly where the cross-section are coming from, with
yes.
all the references appropriate. So it's really nice feature, I think. Yeah.
I think so too, and I hope it will improve the quality of paper. Not that the quality of papers is bad currently, but
No, this is
can
not what
always be
I'm
better,
saying,
of
of
course.
course.
Yeah, I know, I know. But then what you can do is you can download these references, for example, in different formats, and essentially these are just two examples. We have this BibTeX format that you can immediately paste into a LaTeX document for a paper that you're writing, and RAS is a format that is more often used in Microsoft tools, for example. And then we want to couple this to a feature where we can essentially export the table that you see in the top right, also in different formats. So for example, also in a LaTeX format. And what this
Yeah.
does is that you essentially, I only have to click two buttons. I have to paste some text 2 times, and then immediately I have all the correct references in my paper,
Yeah.
and they are correctly mentioned in the paper itself as well.
Okay.
So that makes it very, very easy to correctly reference all the data that you obtain from
Okay.
LXCat.
Okay. This is really interesting. Yes.
Okay, so then one other thing I want to highlight, on the one hand, we
Mhm.
have this reference part, and on the other hand, we have this reproducibility part. So the
Mhm.
idea is that in the future, you'll have one link that points exactly to the data that you selected at that
Mhm.
point in time, and you can just share that with your colleagues. And when they use that link, they see the exact same page that you saw when you
Mhm.
were doing your experiments. And this should hopefully help, reproducibility of results
Yeah.
by a
Yeah.
great margin. And that's what this copy permalink button is for. So if I click this link, a
Mhm.
link is copied to my clipboard, and I can show you that if I
Okay.
now paste this, I get to the exact same page.
Mhm.
And also when versions of the data are updated, so when a contributor makes some changes to one of the data items that you see on this page,
Mhm.
this link will still point to this exact data. So not to
Oh,
the
this is
updated data,
okay.
yes,
Yes.
but to this exact data, which is of course crucial, right, for
Mhm.
reproducibility of
Yes,
results.
yes. It's the same way, when we develop a code that we have version control, right? That we can
Yes,
go back in time to the exact version that we used to produce the results. And this is very cool feature. Yes.
yeah, exactly.
Mhm.
So that's also one of the big things that is underlying a lot of this, is the way in which we version the data, so to say. So in the current LXCat, we have this feature called the time machine, where
Mhm.
you literally just sort of go back in time,
Yeah.
and you can view LXCat as it was in
Okay.
2015 or so. And in the new version, we want to improve on this and actually attach,
Mhm.
mostly exactly like version control, attach a version to each specific data
Oh,
item that
interesting.
is then,
Yeah.
yeah, tracked through time. Um, okay, then what I can still show you is a little Boltzmann
Mhm.
calculation. So the interface
Okay.
that you see here is very preliminary, but it's always nice to see
Mhm.
some lines being generated. So
Mhm.
let's quickly do that.
Yeah,
Um,
because this is anyway still also used largely by the community, so these tools will
mhm.
be provided as well in the new platform. I think it's important to mention that.
Yep, I think so too. So and what you see here, for example, in this gas mole fractions box, is that we can do we can be a little bit smarter here, because we actually know that this mole fraction of the vibrational ground state, of course, is related to the mole fraction of the
Hmm.
electronic ground state,
Yeah, true.
and we can change the interface to reflect this. We don't do that
Okay.
right now, but that's of course something that we can still
Yeah,
do.
yeah. So you preserve normalization, for example, within one state, things like that. Yeah.
Yes.
Okay.
um, oh, I need to
Oh,
input
yeah.
a number of
Hmm.
steps.
And this is sorry, Basic Plus.
This is, yes, this is Bolsi
Okay.
plus. Right, let's
Okay.
it's taking a bit of time, but
Uh-huh. Okay, so here maybe let's describe a little bit also from the viewers that are seeing this thing appearing. So what are you calculating and what is plotted here?
right. So I'm calculating the electron energy distribution function,
Hmm.
which is calculated using Boltzmann plus, which is
Hmm.
a Boltzmann solver that uses the two-term approximation for the electron Boltzmann equation. And essentially, this is only one of the outputs of Boltzmann plus. So that's also why I say that
Yeah.
this interface is very preliminary, because of course we're also interested in the swarm parameters that we can calculate using this electron energy distribution function, such as diffusion coefficients, mobilities, and so on. But that's what you see here. And of course, also a legend is still missing. So this is the electron energy distribution function. So in nitrogen, so this data set that we selected, for different values of the reduced electric field. E over
Exactly,
m.
exactly. So from I think 10,000 until 200,000,
Yes,
right?
yes.
There is this
Yeah.
exactly. And then here there are different parameters as well. And yeah, each curve, as Dan mentioned, is one electron energy distribution function for a value of reduced electric field. So this is a very nice feature. Yes.
Yeah.
Okay.
Yeah, and I think this is what I wanted to show you for now.
And I actually like if you can add, this thing to have a normalization or, vibrational or rotational distribution function that are present in some codes, but maybe it's nice to have it
Yes.
also in the online version, I think.
Yes, definitely. And of course, yeah, it is. We can be a little smarter even where we can assign sort of a population distribution, of course,
Yeah.
to
Yeah.
vibrational substates of an electronic state. And this is something that will benefit Loki, the Lisbon kinetic pulse
Yeah. Yeah.
solver
Of
a lot,
course. Of
for
course.
example.
Yeah.
Yeah.
Okay. Okay, thank you. So maybe we can continue. Okay, so if the demonstration is finished, maybe I can continue with some more questions because I have still some curiosities to ask.
Of
And
course.
then
Should I stop sharing, Luca?
yes,
Or
yes. Okay, well, this was really great actually, and I would like to discuss some of the future work that you are planning, right? Because, for example, one of these things of referencing or having the source in any collisional process that you include is great, but it's also a great challenge, right? I work myself with cross-section sets, and I have no clue where this cross-section come from, right? So I think translating this to the old platform to the new platform, it will be also very difficult, right? So what's your plan
yes,
about that, and what are in general your next steps?
right. So what we are currently working very hard at is to get some sort of public beta version out there, such
Okay.
that people can, start using it, and we get the feedback that we need to develop it even further. And this is so there are two main challenges here, and one of the challenges you already mentioned, which is converting the data from the old format, um, which is a bit so this is a hard thing to do, because essentially we go from a low information dense format to a very high information dense format, and
Yeah.
of course we need to be absolutely certain that we don't lose any physical um,
Yeah.
information during this conversion, and also that we don't add anything, because I mean
That's true, exactly,
yeah,
because
yeah. um, so
this is why I was asking, about this lumped state and so on, because you cannot
uh
label states that are not present, right? If some cross section have been derived in
yes,
another way, you cannot
yes,
attribute, you cannot
that's
use
true.
a state-to-state approach.
That's true. No, definitely that's true. And that's why we've sort of developed this structure in which it's still possible to use this escape hatch and say,
Yeah,
no,
yeah,
this is argon star. We simply don't
yeah,
know any better, which I think is very important for low temperature plasma physics. All right. So one of the things that we are also now working on then is data conversion. But the issue with it is that, or issue, the result is that we need to manually look at all of the
yeah.
data that we are going to be converting, and it is quite a bit. So essentially what we're working on now is sort of a workflow
Yeah,
in
like a
which
pipeline to
yes, in which
automatically.
we can do a bulk of the work automatically, and then we need someone to look at it to finish the work. And of course, it also needs to be validated in multiple ways. For example, we have Boltzmann solvers that can use both the legacy or the current format, the current LXCat format, and the new format. And for the same data and the same exact parameters using the different formats, they have to get the same results, for example, right? So these are
Yeah,
tests that we need to do before
yeah,
actually making the data public.
yeah.
But
And this is, I think, one of the things you mentioned before. This is why I think LXCat should not be really one individual contribution or contribution from a restricted group of people, but a community effort. I think
yes,
especially. And this is why also I hope in a minimum part, this podcast also will help to attract people. This is the reason why we are doing it. We are spending our
Yeah.
time, I hope.
No, that would be absolutely great. Yeah, we can use help in a lot of ways because of course the LXCat team is always looking for data contributors on one hand, but and up till now it has always been very hard to attract people for other jobs, right? To
Mhm,
develop a small part of LXCat, for example, also because of the way it is set up and
mhm.
there's no clear documentation that we can share. It's not open source, and those are also things that we are trying to do and hoping to
Yeah, yeah,
be a little
yeah.
more open to
And
yeah.
in terms of your work, like let's say immediate next steps, is there something you are looking at, even like incremental improvements? What are you working on?
um
If I may ask, if
yes.
it's not a
Yeah.
secret.
No, it's not a secret. We have already presented some of this as well.
Exactly.
Um, so immediate things that we are working on. We are always working to refine sort of the schemas that we've currently defined. So that's something that I'm working on right now. There's still many things on the development side, the web development side,
Mhm,
but maybe more interesting is sort of the expansion to
mhm.
chemistry, right?
Ah,
To
true,
also
true, exactly.
incorporate neutral chemistry, for example, so heavy interactions, because essentially this platform was already built with that in mind.
Mhm,
So it should very easily be able to be adapted to also support this type of data. And that's what we're working on right now. So we're working on defining the initial schemas that can be used to define chemistry data, essentially.
mhm.
And that will then be expanded into also,
Yeah, yeah.
updating the
It's
database and website.
yeah, it's a very, very interesting ideas, to have a sort of also set of reaction mechanism for a specific type of application in a specific regime. It would
Yeah.
be very interesting, also very challenging, I think.
Yes.
But it's a good step forward, I would say, of the whole community if we go in that direction. So.
Well, I think it would just be because you are probably familiar with the struggle that is
Mhm.
um, especially present if you go towards chemistry, where it
Yeah,
is it
also
is
reproducibility. I mean, not just
yes, yes,
yes, yes.
it is simply very hard to even get the data correct,
Hmm.
right? Only the data part. We're not even talking about the simulation itself,
Hmm.
but just to extract
Yeah,
the exact data and
yeah. In fact, we started this episode saying in the beginning what is the importance of LSCAT for our everyday use, right? If we make a model, we download the cross section. I hope, in some years from now, or 5, 10 years, I don't know, also people will say the same for chemistry part, right? Yeah,
it would
I
yeah
cannot imagine a world
yeah yeah,
without a chemistry database, right?
yeah,
So
that
I
would
hope
be the
that
dream.
people,
Yeah.
will not know about this struggle. So this is a good goal,
Yeah.
I think, for.
Yeah, yeah. Yeah, that's definitely the goal, and hopefully in the upcoming years we already see a glimpse of this.
Mhm,
Um, but yeah, I think big projects like these they need some time and definitely also community effort, right? This
mhm.
is not something that we can do by ourselves. I mean,
Yeah, yeah. Okay, to conclude, you mentioned these educational tools. This was also one of the comments by Professor Stefan Reuter, if I'm correct, at
yes,
the ICPIG. So,
yeah.
do you have something in mind, which type of tools the community may build in the future or can contribute, for example?
Right. So what we are already working on within LXCat is sort of a list of topics on which we want to make videos.
Okay.
Just small videos that explain a very specific part of either plasma physics or LXCat or numerics or whatever
Mhm,
that are important to the whole LXCat project and to low temperature plasma physics in general. So of course you have that, but I'm also thinking about, I think Stefan was specifically talking about material like a presentation that
mhm.
can be used to introduce LXCat to your students.
Yeah, how to use the
Um,
platform and so on
yes,
also,
yes.
yes.
So written,
Mhm,
that's essentially written tutorial in a way.
mhm,
But I'm also thinking of yeah, just more practical tools that you can use to interact with LXCat or to inspect data that comes from LXCat that you can also maybe use in an educational setting. So,
Mhm.
for example, we have a Python library that
Yeah,
you can
yeah.
use, and we have a Python notebook, an example notebook of how you can extract some data from LXCat and then inspect maybe the threshold of a cross section or whatever. Just examples like these. And I think this is also a great way to, um, create
Mhm.
educational value.
Yeah, very, very interesting. Because I was thinking, the same about some like models, for example, if you have Monte Carlo simulation or fluid and so on, and you can have this type of educational tools like
Yeah.
codes
Yeah.
for the students to learn. But to interface these also with LSCAT, it is, I think, an interesting idea, probably. Yeah.
Yeah. Yeah. Yeah, so this is something that we've not really talked about now, but that is also possible, right? In the
Mhm.
new
Yeah, of
in
course,
the
of
new
course.
version of LXCat to interface directly with LXCat. So for
Mhm.
models to obtain their data by just talking to LXCat directly.
Mhm.
And this is of course also where you could, think of such a Python notebook that is just an example of how
Mhm.
you can do this. That might teach people of how to integrate this into
Yeah,
their
yeah,
own
yeah.
tools, for
Or
example.
yeah, exactly. Some, having some libraries that are shared by the Plasma community and you implemented in different functionalities. I don't know. It's
Yeah, yeah,
very, very
yeah.
promising anyway. But okay. With this, I think I would like to thank you very much, Dan. Maybe, if there will be important progress and updates, we can keep in touch to make also some other videos eventually in the future. I would
Sure, yeah.
really appreciate. And with this, yeah, thank you again for your time, and I wish you the best for your future. And I'm really looking forward to see this LSCAT 3 actually
Me too.
appearing.
Thank you, Luca, for having me.
Thank you.